This section is a reminder, okay, that if you add a number to both sides of the inequality, sign won't change. Or zoom in. Okay, if I add any number to both sides of the inequality, there is no change to the direction of the inequality. It will stay what it is. Same thing, if I were to subtract this side, if I were to subtract, there's no change as well. Okay, wait, I need to squeeze in here. If I subtract, sign won't change. So this one you all learned before already. Okay? But if you multiply, okay, when we are talking about multiply, if you multiply by a positive number on both sides, okay, I don't write like that, number, okay, sign also won't change. Same thing, if you divide by, like this one, you multiply by a positive number. This one, you divide by a positive number on both sides. Sign also won't change. So these are all the scenarios where the sign will never change. Plus, minus, times, divide. If you are adding, subtracting, multiplying, or dividing by positive constant, it shouldn't change at all. The only instance where it changes is these two cases. This one and this. When you multiply or divide by negative number, you need to reverse the sign. Okay, reverse the sign. A typical example, if I say 5 is greater than 3, right? But if I ask you to multiply both number by negative 1, this one becomes negative 5, this one becomes negative 3. You all know that on the number line, negative 5 is smaller than negative 3. So, can you see that the sign reverse when you multiply by negative number? So, it's the same thing. When you divide, the same thing happens. Only when you multiply or divide by negative number. So, this is something that you have learned in Sec 1. Okay, nothing new. Okay, nothing new. It is just a recap. This one you have learned before. Okay, and then if we go next page, there is this thing called the transitive property of inequality. We are waiting for. All good? Not yet. Can I? Okay. So if I say that A is less than B, and then B is in turn less than C, I can conclude that A must be less than C. So this one is something that we know. For example, if I say that, who's the tallest person in the class? Okay, a tall person, Raj. So if I say, okay, give me somebody who's taller than Raj. Okay, so if I say that Hashid is taller than Raj, who is taller than Hashid? Vishan. So Vishan is in turn taller than... Why? They choose themselves, not me. And I say Vishan is taller than Hashid. Then by transitive property, I can conclude that Vishan must be taller than Raj. So it is just to link the three variables together. Okay, so this is transitive property. Nothing scary about that. Okay, next is also what you have learned in Sec 1, how to represent on the number line. So if I say x is less than negative 4.25, if it is a strict inequality, the circle is hollow. Okay, maybe I just draw on top. Hollow, right? You do not include hollow circle. Do not include the endpoint. Why? Still figuring the height. Okay, so lesser than negative 4.25 points towards the left. So the lesser part is always here. The more part is always here. Okay, but when we say less than or equals to, for instance, if I say x is less than or equals to negative 4.25, then you need to shade the circle. This is a solid circle. It includes the point. So the shading is important because you need to learn how to represent a number line. Okay? So when you shade the circle, when it's hollow, it makes a difference whether there's equal sign under the inequality or not. In Sec 1. Yeah, so recap of Sec 2. Okay, so recap only, that means all this you know already. When I teach at the later part, all this I assume you know already. Okay, then greater is pointing towards this direction. Greater or equals to, you shade. Okay, so all this, your foundation knowledge. I'm just recapping so that everybody starts on the same page. Okay, now, solving. You also learn in lower sec. So in solving, we will treat this like an equal sign. Next class. Can lock? This one? Okay, continue. Okay, can. So we will subtract 3 on both sides. We know that subtraction, addition will not change the direction of the sign. So this will stay status quo. And then when you divide by a positive number on both sides, there's no change in the sign as well. Yes. So x is less than 6. This is the whole solution I want. Remember, for inequality, solution is a range. You don't tell me on the number line you put answer as 6, then you lost your answer mark. The whole x less than 6 is the solution. So represent the solution on the number line. Wherever you draw number line, you must show me where the 0 is. So I know where's the left, where's the right. So 6 is here. So hollow circle, point towards this direction. So this is x less than 6. So this is the number line. Okay, all these are still the simple one. It will get more complicated, but it's still manageable. Can all this quite okay, right? Not okay, you can secretly tell me or openly. Okay, this one. Same thing. We add 8 to both sides. Adding will not change the direction of the sign. So this is 3x. This is plus 24. Okay? And then we subtract 7x on both sides. Subtraction will not change the direction of the sign. Yes. of negative number. Of negative number only. Okay, so now here's the part. When you reach this phase and you want to get x, what do you do on both sides? Divide by negative 4. So when you divide by negative 4, that is where your sign changes direction. So this is the part that you cannot miss out. The rest is just normal calculation. Okay, so your solution is this thing. X greater or equals to minus 6. So on the number line, show me where the 0 is. Shade the circle because there's an equal sign and then greater. So this is the solution I want to see. No need. Okay? Yes. Okay, if you want to be explicit, showing all the markings can. Okay? Okay, next one is what if you have two fractions on each side? What do? You dance? You what? Times. Okay, so you times. Okay, there's many ways to times. What is the way that you will times? You cross multiply, right? Okay, so this one very important. If it's an inequality, you cannot anyhow switch position. Because when it used to be equal, right? When you're cross, you also change the direction of what the things were on the left and the right. But for inequality, right, the numerator must stay where they are. You cannot suddenly switch the position of the two numerator. If not, it becomes invalid. So this is very important. So in lower sec, right, my students say whenever we do cross, right, then they say look like what? Got any Marvel superhero do this? Is it all this Wolverine? No, yeah, they say we do a Wakanda. Okay? So when you cross multiply, they say do like this, right? The 7 goes up to that side. Right? The 7 goes up to that side and then the x minus 4 stays. So this is super important. Now you might think it's trivial, but very soon when I start to quiz you, I will have people switching the order. So cannot do that. So same thing, this must also stay where it is. So the 2x plus 1 stays there and then the 5, you shift it over. Then the sign you just copy. So remember, numerator must stay where they are. Okay, so that's why I don't like cross multiply, because y'all will make mistakes like that. Usually what I do is I like to multiply by LCM. So everything stays where they are. So like this one, when you multiply, then left 7, right? So you know it will stay here. Same thing here, this one left 5, you know this will stay here. Okay, so LCM is another way, but the inequality stays where they are. So this is important. Okay, but cross multiply also can. Okay, then you just do your normal expansion. Then the rest is just your solving. Okay, I think some of you will just switch over and add, right? So you can just do that. I'm just being very explicit in my steps.
Can you like make it so that x is like never than
Can. Then you just shift all the smaller x to the other side. Okay, you can always do that. Okay, and then this one is subtracting 10x on both sides. Then you get a negative 3x. Right? So if you divide by negative 3, that is where you need to switch your sign. When you divide by negative number, the direction of your sign change. So this is your answer. So this is the only part you need to be careful. Okay, so try to make sure when you cross multiply, your numerator stays where they are. Then number line, 0, negative 11. Shaded circle because there's an equal sign, goes this direction. Okay, the good thing about keeping the X here is the arrow points in the direction that you want. But if you shift the X to where it will be positive, then you need to read it. Okay, if not, it will always point in the direction that it goes, if X is on the left hand side. Okay, so this kind are still very, very manageable. The PMP, I leave it to you to just practice. I don't need you to hand in this piece of work to me because it is lower sec revision. Okay, can we move on to simultaneous linear inequality? This is your sec 3's work. This is the real sec 3 work. The front part, all lower sec. Okay, so we are done with recap. Let's move on to 2.2 now. Okay, simultaneous linear inequality, like the word simultaneous suggests, is that you need to solve them at the same time. They must fulfill both inequality. So if you solve this, right, you plus 8 on both sides. Okay, and then you divide by 5 on both sides. Left hand side, it says that your X must be less than 4. And then on the right hand side, your X will just be 2. Okay, so you need to fulfill both inequality. So put both of them on the number line. So if this is 0, 1, 2, 3, 4. So this is X less than 2. This one says X must be less than 4. So you need to find your final solution in the overlap. So where they overlap, it's over here. So everything that is less than 2 is where the overlap is. And then you check. At this part here, it's a hollow circle. So your overlap do not include the 2. So your final answer is X less than 2. Okay, which is the overlap here. So your final answer, it is X strictly less than 2. It does not include. Okay, so you solve both separately and then find the final overlap in the solution. Okay, try example 2 on your own before we check together. What if we finish inequality in one day? Yeah, looks like it's very possible. Then that means tomorrow we quiz and then we go A-math again. Okay, try example 2 on your own. Just treat them as 2 separate inequality and solve them. Shouldn't be tough. Inequality question is a giveaway. Don't make careless mistakes. Okay, your two intermediate solutions should be x less than or equals to 1 or x greater than negative 4. But what should your final overlap look like? Okay, the two endpoint is clear. It's between -4 and 1. Or your x is trapped in between. The issue is whether to have the equal sign or not. So if you look at this excludes negative 4. So it's a hollow circle. There's no equal sign here. Okay, but this includes your 1. So when you write, there's a equal sign for the inequality. So your final solution set is this range here. It's a bounded inequality. Okay? Oh, I think cannot. We got no time to do application. So sad. Why I hear like yes. Okay, sure. Okay? Can quite direct and simple. Just solve them separately. Okay, but example 3 and 4, they put them together. So let's look at how to split it up. So remember, when you are given a simultaneous inequality that is bounded, you split them up into 2. So you recopy this as one inequality to solve. And then this one, like your transitive property, split them into 2. Like this was Raj and Harshit, and then Harshit and Rishan. Split them up separately, okay, before you compare them again. So you are supposed to solve both of them separately now. Okay, so the solving should be easy enough. Okay, divide by positive number, no issue. Okay, just make it a good habit to change to mixed number for E-math. A-math don't care. A-math just improper, decimal, surds, they like. Okay, I like to always add the same thing on both sides so that you will less likely be making mistakes, because I will have a group of you who will give me the answer as 6/7. But if you do it this way, you rarely have this issue. Okay, you will rarely have this issue. So if you do the same procedure for both sides, you will be less likely to make mistakes. Okay? So 2 sets of solution. So 1, 6 maybe here. Okay, so final solution is all the x greater or equals to 1 whole and 1 6. Okay, the PMP on the next page, you all can just do on the spaces provided. Double check your solution. I think it's worth doing to make sure that you don't make careless mistakes. Okay, so just to point out, last one, split into two. So every time you all forget how to split, think of Raj, Harshit and Rishan. Okay, compare 2 by 2. So this is the other two to compare. Okay, and then when you see fractions, you can do a Wakanda. So put a over 1, and then you cross multiply. Remember, the numerator stays where they are. If you are confused, then think about multiplying by LCM. Or there's this button somewhere on the computer one, right? I remember seeing this button somewhere. Just remember, the numerator stays where they are. Don't anyhow switch position, ah. Okay, the rest is just solving. Okay, I like to always keep the X on the left hand side. Okay, so two final solution. -5 and 1. So X less than -5. X greater than 1. Do they overlap? So if they don't meet, there's no solution, that's all. That means this whole range that they write there has no solution. It's unsolvable. Okay, so you just write no solution. Can I think it's a good time to finish. So today you go back and do this. If you have a bit of time to spare, look at the inequality there. It's all doable. Okay, but we are almost done. Optional? No, you just do on the space here. Quick one. On the way back home, on the bus, you can just scribble here. Then one more thing. I think the AMF PMP that you all haven't hand in. The previous one, I forgot which one it was. There was one PMP I say bring home and do your revision. You all remember? What was it called? Okay, never mind. What was it? PMP what? PMP what? 1.2. AMF 1.2. Have or don't have? This one is the last year. Oh no, still got job. Still got job. Okay. Fast forward. Inequality is E-math, yes. For E-math, 2 chapters. Right.
I think that's one.
Okay, then you pass me tomorrow. Can? Yeah.
Can I see you for consultation?
Can.
2:45.
2:45. Okay, my meeting ends at 3:45. Yeah.
Or is tomorrow better?
Yeah. Tomorrow maybe. Should after school?
Okay, sure.
Tomorrow better. Any more? Okay, I see you again tomorrow. Thank you. Okay. Is the teacher outside? Yeah. Oh, okay. Sorry. Ah. Sorry. This one keeps, the wind keeps blowing, so it keeps banging. Yeah. Later, we'll see each other later.